Okay, we looked at some derivatives, but what if x is part of the exponent? Or it's part of a logarithm? What do I do? Or maybe it's part of trigonometry? Well, we'll cover that in this video. Alright, all these derivatives over here are very easy. In fact, you memorize all of these. And they usually come with chain rule attached to them, but we'll explore that later. So, for these derivatives, especially for e to the x, the easiest derivative you'll ever see. It's basically the same thing, e to the x. E to the x, however, is e to the x times ln a. What about ln x? It is 1 over x. And the derivative of log x, I should say log base a x. 1 over x ln a. If not, it would be ln 10. And that's it. So, how will chain rule apply? Let me show you. So let's say I'm asking you to take the derivative of e to the 35x squared, let's say. So, the inside would be the exponent here. So all you're going to do is take the derivative of the outside, keeping the inside. So you're doing e to the 35x squared. You keep the inside. And now you multiply by the derivative of the inside, which is this here. So it would be 70x. So that's it. For each of these, the inside would be wherever x is. That would be your inside. So let's say I'm doing for log base 2 of 3x squared. Okay, I'm going to take the derivative of that. To take the derivative of that, I have to do first derivative of the outside. So 1 over, this would be 3x squared, parentheses, but you don't need it, but ln 2. And now, multiplied by the derivative of the inside, so 2 times 3 is 6, x, simple power rule. And then you could put the 6x here and divide and simplify. You know, you could get 2 over x ln 2. And even with the chain rule, these don't take that long. You'll probably finish these in 10 seconds or less. Now, the best part of derivatives as a whole is that they really don't care about coefficients and constants that much. And the same applies here. So if I ask d over dx of e to the x, but I have a coefficient of 6 or any number, it's basically the same thing. I don't have to worry about any kind of mathematical operations I need to do for this 6. It would behave the same way as it does for x. You sometimes multiply, if not, you just leave it as it is. Alright, the last thing we're going to cover today is the basic trig derivatives. So to take the derivatives of each of these, it's basic memorization again. This is very simple. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tan x is secant squared x. The derivative of secant x is secant x tan x. the derivative of cosecant x is negative cosecant x cotan x, and the the derivative of cotan x is negative cosecant squared x. Okay, now this is a lot, so I'm going to break this down for you to memorize easily. So the positive ones are the ones that start with s and t. The negative ones are the ones that start with c. If you observe, all of these are negative, and all of these are positive. So the co-functions are negative. The regular functions without the cos are positive. Okay? So that's the easiest way to remember the sign. Or, yeah, sign as in the operator, not the function. Okay, now let's look at this. For sine and cosine, think of them as a pair, okay? So for sine, you get cosine. For cosine, you get sine. And you know which sine operator to use for each. Now let's look at tangent and cotangent. They also have the same structure. For tangent, since the s and t are a pair for this positive ones, right? They're going to be the same. So you get secant squared. And for cotangent, it would be cosecant squared, but negative. Alright, finally, the secant and cosecant, they're the pairs. So, for secant, since tan and secant are related, right? We have seen that. Secant x and tan x. For cosecant, negative cosecant x cotan x. Yeah, so take a moment to memorize these. I know first time it might be confusing, but you'll get used to it and it becomes intuition later. Now again, the chain rule is very prominent in these problems, right? So let's see that. So I'm going to take the hardest one here, and I would say that's cosecant x, because you're getting another function that's added upon here. So I'm going to use that one. So let's say I'm going to take the derivative of, let's see, CSC cosecant x, but instead of x, I'm going to have x cubed, let's say. Okay. So to do this, I'm going to do negative cosecant x to the third cotan x to the third, and then the derivative of the inside, 3x squared times 3x squared. Again, it's the same thing, so it's going to be very easy. All you have to do is, when you're taking the derivative of the outside function, you just substitute whatever was in here for x all the way through, and then multiply by the derivative of the inside. Pretty easy. Alright, here's a practice problem for you to do. See if you can identify any other rules along with the chain rule I've incorporated. Well, did you identify the product rule? If you did, you probably did it right. But here's my answer. Check it out. Well, thanks for watching, and see you next time.